Hello, hello everyone. How are you doing today? All right. Let me just check if we are live also on YouTube as well. Right. Perfect. We are also live in there. Just close this. And we're good. All right. Thank you for coming back. Maybe in the future, but not right now because we have 0 people watching this at the moment. And yeah, so as we have been doing for the past several days, we will try to do some coding challenges or some solving some programming problems. And for that, we're using this site called CodeSignal. Right now, I think the last time, yeah, we are almost done with the core section or the first part of the arcade. And the arcade is just like a predefined set of problems that the site is proposing for you to solve. And right, so let's jump into it, right? You know the drill. On the left, we have already the description or the problem statement, similar to the ones that you may get whenever you are doing some coding interviews. And on the right, we will have the solution or where we are going to implement the solution. Cool, cool, cool. Let's see. Let's read it, right? So given a position of a knight from chess on the standard chessboard, find the number of different moves the knight can perform. The knight can move to a square that is 2 squares horizontally and 1 square vertically, or 2 squares vertically and 1 horizontally away from it. The complete move therefore looks like the letter L. Check out the image below to see all the valid moves of the knight piece that is placed on one of the central squares. All right, cool. Yeah, we see the way that the knight can move, right? So it can move this way, this way, this way, this way, this way, this way, this way. Cool. So, and then we see that if the knight is in A1, it can only move to 2 places. If the knight is in C2, it can move to these 6 places, right? And the notation is standard chess notation. All right, I think it's what can we do, right? So I guess we could check, you know, how far away is the knight from the edges, I think. Because if the knight is in a position, so if the knight is in to say the least, right? To say it, to do the simulation in my head. So if the knight is in the C column, then we know that it cannot, that it can move everywhere, right? So if the knight is in C or G, we know that it can move to the right at any place. And then if the knight is also in the 3, it can also move everywhere, right? So, and if the knight is in the V column, we need to remove 2 at least. And if the knight is in the C column, we know that we should remove at least Yeah, everything, right? Mm. How do we do? We can do it, yeah, in two ways, right? So one, we figure out the um, the possible moves, and then count which one of those are possible based on the position, or we can try to figure out like a formula or something like that to know how many of them, right? How many of them are valid. Mm, okay. Mm, I guess we can check, right? So if a cell is what C, sorry, more or equal C, then we know that all are available in terms of X. Well, if it's sorry, it is, well, if C is equal, better this way, and then this through F as well, right? And then also same, but this case 3, and then this should be what, 6 in terms of Y. Okay. Okay. Okay, so this should always come. Let's just get right. Um, yeah, whatever. Then cell. Sorry. X is cell chart on 0, just to get, and then Y equals cell chart at 1. Right now we have this position. So if X is then in this case, is it lowercase? Yeah, so it's lowercase. So this should be, whoop, sorry, C, right? Sorry, my keyboard is breaking down as always. Okay, and X is no, wait. Let's just put it like this, right? So C, if it's smaller or equals than X, and if also is more than equal than F, then we know that it is in the range on the X's, right? So we know that at least we will have 4, right? Looking at the numbers, at these numbers, right? Because we know that, yeah, that it can move to the next and to the second next, and then same with the other one. Let's see. And then I mean, we can always just transform this into numbers and then just check +1, -1, and then do the counting. But no. Now I want to solve it in this way, right? Okay, so now we know that it's in the thing. No, let's see. Minus a. Sorry. And then this is minus 1 because it starts with 1. And then just transform this into int. Okay, now if x minus what 2 is smaller than 0, yeah, then we know that things on the left cannot be done. Okay, let's just go with that, right? So we know that there can be 8 moves in total. So if we go -2, then we know that we cannot move for 2, and then we decrease result -2, right? And else if x -1, well, x equals 1, and this should be the same, right? Else x equals 2, then result should be -1, right? Okay, so that covers the ones on the left because there is no point on trying those, right? So if, let's just return result. Okay, now what if, yeah, it is valid, right? So then we know that we are on we know, okay, let's see, if we are in minus, no, wait, so we have, so if x is in 0, then it's -2, right? If x is in 1, then it is -2 as well, right? No, sorry, this is -4. -4 because everything on the left, it's it cannot be, you cannot move on the left, right? And then if it's 1, then we just decrease 2 because there's only 2. Okay. Okay. And okay, if it's on the, okay, or x equals what is it? 0, 1, 2, 3, 4, 5, 6, or 7, right? So this is 7. and this should be 6. It's the same. We remove the last 2 or the last 4, and then here we will check, right? So if y is so assuming that we are on the last thing, if x is 0, or sorry, if y is 7, then we will remove 2, right? So result -2, and in this case, if x is 1 or 6, and then we are on the last thing, we will remove also 2. But if it's just so if it is on B2, for instance, it should be fine. But if it's on so C, okay, this is a scenario, right? So it doesn't matter. No, yeah. So if it's on, so it should be. Yeah, it doesn't matter. It needs to be on 3. Yeah. -2 or x -5, right? 5. Then this should be same. Okay, now if we have okay, now if we have y -2 or y equals 0, then we will, and yeah, y equals 7, then we will remove 4, same. And if not, we do the same. And the result -2. Then we do this, and yeah, we don't really check for the others because we did it already for the previous steps. Does it work? Doesn't work. Why doesn't it work? In most of the cases. What did we miss? G8. Okay, so G, that means that is on x equals 6, that's 0, 1, 2, 3, 4, 5, 6, yes. So we are here, right? And then, because it's 6, the possibility for the ones on the left, yes, it should be 1, 2, 3, 1, 2, 3, right? Right, so we just remove entirely these 2, and then if x is smaller than 2 or bigger than 6, minus 2 more, but it's not the case. It should be so in this case y is 7, Yeah, it's okay. Yeah, it's not the same. Right. So in this case, if y is, let's see, if y is 7, meaning if we are asked the end or the beginning, then we need to completely remove 3, right? Because we already removed the missing from the right or from the left. So, right. And then else, if it's 1 or 6, okay, so if we are on 6, it's only 2, right? Yeah, I think so. Right. Let's see. Perfect. Perfect. I wonder if there is a better solution, probably. All right, so let's see. What is this guy doing? So 2, 3, 4, 6, 8 results. Okay, so all the possible solutions, right? So minimum between this and this and 2, what? Sin distance attention, I'll put some more to the scaffold. Let's see. Let's do this Java. So you have initially it moves, right? So if it's in the from B in B or G, yeah, -2 of course, and then if it's okay, -2, and then just, divide, yeah, okay, yeah, it's not so clever, but let's see this other one. 2 moves in corners. Okay, yeah, here 2. 3 moves against the edge. 4 moves total. 6 moves total. And then 8 moves. Score from the edge. Wow! It's interesting. This solution from Mark. Okay, so 2, 3, 4, 6. And then just gets where is this guy, right? In which section? Nice, nice, nice. Let's go to the next question. Now, given some integer, find the maximal number you can obtain by deleting exactly one digit of the given number. For 152, the output should be 52. For 1001 should be this. Given some integer, find the maximum number you can obtain by deleting exactly one digit of the given number. So what should be finding the smallest number and delete it, right? Delete that number. Sorry, the smallest digit. Technically, yeah, right? So let's see. Uh, let's see. How do we do it? I mean, another thing we can do is just iterate and remove one in all of these and just check which one is bigger, right? Um, I guess you can do that, right? Now, how do we do it? Mhm. So, mm, what we can do is, mm, 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 I'm thinking of transforming everything to a string, just replace that. I mean, building this with strings and transform them into integers. Mm, but I don't know. I think it doesn't. It's not that good, right? So let's just check. Find the smallest digit from left to right, and then remove that digit. Right? And then the result. The solution is just to another solution would be, as I was saying, right? So remove every digit and then append it. Um, and just check which one is bigger, right? I don't know. I don't know, Rick. Um, yeah, let's see. So classic way and bigger than 0. Then just let's see, index and then int mean, which would be this one. Bu- 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 bu. Yeah, I guess we can do it with strings. It's better, faster, instead of doing it like this, right? So, string, and do we have to string? What is it? Integer to string, right? And then just check. Mm, 2, 4. Um, 10 dot length and plus plus I. Right, so we can do, what is the max number, right? Um, yeah, I guess we can do it like that. Not the best, definitely, but it will work unless we have some limitations with the performance. But this will work. So, right. So temp substring. No. Substring, right? From 0 to I plus substring from I to whatever plus 1. Then just check, sorry, string to int, or is it parse int? From string to integer. Java integer parse int, yes. Thank you. Parse int. We don't need to. And then, yeah, what we had here, right? Then this one, nope. Yeah, and then result, boom. Max, yeah, yep, this should be here. So yes, let's see it. Perfect. We didn't even need to find out which digit was the one that we needed to remove. Let's see the solutions. Math, okay, yeah, this guy knows how to remove it. Max, and let's get the last digit. This one times the, okay. Okay, so this gets the last part. This gets the first part, right? Just split the thing. Okay, yeah, better. I don't know how to do it like this, right? Yeah. Okay, yeah, this guy did it like me. The strings. Parse int. This guy also did it with strings. Yeah, but I guess this is the way to do it, right? So you have D, which is which digit are you going to leave out, right? So initially you will have the first digit, the one from the right, and we'll just attempt to get the mod from that, and then get the other part times this, so you get it. So this should be the other way around, but it doesn't matter, right? Because the sum is just the one on the thing that we see here on the right. It will always go to the left of the number because the thing that we are multiplying will be bigger than the remains of this. It's just a bit confusing that the guy did it like this in this way. But all right, pretty good, pretty good. Let's do the next one and last part of this journey. So define a word as a sequence of consecutive English letters. Find the longest word from the given string. The output should be solution text, steady. Guaranteed constraint. Text contains at least 4 characters. The longest word from text is guaranteed that there is a unique output. All right. I mean, we can iterate over it or just split it, right? So just return what? Oh well, just for no string x text split all. What was the thing? This word Is it? Is it valid ones? I'm not escaping it. I want to use a. Oh wait. Split by regex Java. No JavaScript, no Java. Let's search for it. Split, split, split. Yeah, it's a split then. So it's a split. Then it should be this. No. Okay. Alright, this will give us W means for word characters, and W uppercase is the opposite of it, right? So we're splitting by everything that is not X. And then just result should be 0, not max, X dot length, and then result, we will just get it, right? And then just return result. Let's see. What typo? Ah, no, wait. Okay, so, right, then let's just check. Sorry. Then int max equals 0. Max. Okay, let's do it like that. Right, so max, then x of length. If max is different than result of length, then result is equal to x. No. This should be result, right? At that length, and this should be max. Yeah, I think this should work, right? So what we're doing is just get the result initial with an empty string, split it by all the characters that are non-word, and then just find whenever we have a new max or a new bigger string, and then if the length of the bigger string is different from the one that we have, from the length or of the string that we are planning to return, then just change it, right? And it will work, or it works. Nice, let's do it. Oh, what happened? One hidden test is failing. Huh. Wait, do we have solutions to see already? No, right? Until we have the solution. Which is it? More, do we have README solutions? No? Beauty. Okay, done. I don't want to reveal it. Take me back. Okay, so what is happening? All the things that are non-word, we have max equals 0, then just returns this. Wait. If max is bigger. No, but this is right. No, this should be. It's the same. Yeah, probably because we are. No, but it's the same. Click the run test button to see output console logs. Submit button to prevent hard coding solutions for. Unlock hidden test. What? 10,000. How many do I have? How many coins? 200. And to see a solution needs what? Real all solution for 200. Yeah, I think it would be better to see solutions, no? What? It's crazy. Why? Okay. Past 9 out of 10. Run test. 5. Okay. Steady. Steady as well. A, B, C, D as well. Here not to be as well. Code finder ever. Right. 9 out of 10. So this one is the one that is failing. But why? Why is it failing? The longest word from text guaranteed that there is a unique. Let's find the longest word from the given string. I'm splitting. So max is so maybe if this is a -1, in this case it's not result x result that max, then just change to the new result x length equals max. Would that be the case? There was a problem? No. Shit. What was the problem? Interesting. I don't know. Let's see. It can be a solution of the solving question. Yes. Let's just reveal for 200. Run balance. Yes. Reveal it. So this is what we're trying to do. Okay. So split. Okay. Get the max from get. So the same. Okay, just split, get the max. Elan. Let's see, JavaScript, get it, plus turn. Get it. A to C, A to C. Length, here's an T length. Sure, just so exactly what we are doing. Maybe we have a problem with this, and we need to do it like that. Up. Continue solving. Let's see it, right? So this works. Max equals if max figures and the result of length. And this should work. What? Why is not working? It's the same as the solutions. The same as pretty much this one. Right, so you compare one and the other. Get the max from the lengths of these. Just return it. What's happening? Same here, right? So you are comparing it. Maybe we just need to do this instead of the other split, because could be that is wait, what we were looking at? No, this is not. The text split. Yeah, just get it, right? That's what we are doing here now. Yeah, so it should work. Pretty sure it should work. Result that is smaller than max. Max. Wow, so the problem was the regex. Interesting. I wonder why. Yeah, let's see. Op, regex Java. So what does this W mean? Ah, okay. Right. So non-word character. So yes, the problem was this, right? That it was maybe included in, yeah. Makes sense. Makes a lot of sense. Okay. Cool. Let's see. And we got the 300 back, so let's continue. Now this one, check if the given string is a correct time representation of the 24-hour clock. So looks somewhat similar to the other ones, right? So we need to always evaluate the string and see what's in it. What's in it? So the output should be right. So let's see. I guess we can do it with a regex. Now that we are getting better with these regex things, let's try to do it. So the first one should be what? 0 to 1, and then it could be what? 0 to 1, and then from 0, wait, can 0, 0 be true? 0 to 9, of course, or just a digit, right? Let's just check digit, yeah. Okay. Whoop. Digit or or 2 and what? 0 to 4, right? And then the colon, but I don't. We will probably get it super wrong in the beginning because I don't know how to do it on top of my head. This thing, like, sorry, no, it's not 24. It will never reach 24, right? So it's 23. Then for this one would be from 0 to 5, and then this other one would be what? D, right? Let's see. Oh, wait. Compilation error. Does it work? Perfect. Yeah. Seems like I remember. Excellent. Pretty good. Yeah, it's just regex, right? So we need to check, and then I just did like from 0 to 1, meaning like from 00 hour to the hour 19 should be valid. And then for the or from the hour 20 to the hour 23. And then on the time of the minutes is from 0 to 5, and then, sorry, from 0 minutes to 9 to 59 minutes, right? I'm expecting for all of this to be, I don't know, look, I was expecting for everything to be A regex. Turns out no. Okay, yeah, I mean, it's good, same. Okay. Practical, just try to transform to convert into the date. Test, yeah, same. Cool, let's move on to the next question, and maybe after this we could take a small or take a break for the day. Right, let's see. So now, um, oh wait, I'm missing the browser. What? Why is not here? Okay. Oh wait, no, it is here. I just need to put it into the front. 1 second. Order. Move to the top. Is it? Order, move up. No? Transform, rotate. Why is this not showing? Let's move to the bottom. Set color. Why is it not showing? Enable preview, loud preview. Sorry, I'm trying to see the. So the scenes is not here. Linux. Properties. Why is not showing? Interesting. Alright, so it is not showing. Okay, yeah, sorry. Um, okay, let's see. Oh wait, the music stop. Why? Why? Alright, so Codemaster, yeah, okay. Let's read it now. Codemaster has just returned from shopping. He scanned the check of the items he bought and gave the resulting string to ratio RG to figure out the total number of purchase items. Sorry, since ratio RG is a bot, he is definitely going to automate it. So he needs a program that sums up all the numbers which appear in the given input. Help ratio or by writing a function that returns the sum of the numbers that appear in the blah blah blah. Okay, so this one um, cool. So we will do something similar to what we did last time, right? So we will split it into everything that is not a. We will split the string into everything that is not split string in into all the things that are not digits. Iterate over it. Sum the digits, so or the numbers, right? And then return result. And we're missing an R. Probably there's also a guarantee that the maximum sum that will be in this is not the biggest value of integer, right? It's an assumption. Okay, so x input string split pop. Then this should be oh, sorry, no, the uppercase, right? So everything that is not digit, and then result plus what is integer, parse int, right? And then x, and then that should be it, right? Okay, so what's happening here? There's the type mismatch, blah blah blah, for input string. Okay, so let's see why. No digits at all, 0. There's invalid, 3, 2 apples. Bam, 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 so this is stop here, right? There are some 12 digits. 5, 5, 6, 6, D, 7, 7, 0, string. Bam, bam, I mean, we can always if x applied to 0, bigger than 0. Bam, 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 solve without hints, 186 frames, more than the average 17. Okay. Bam, bam, bam. Similar, so find it all, then sum all, yep. Then similar, find all digits instead of splitting them. Then transform, right, yeah. Given a rectangular matrix containing only digits, calculate the number of different 2x2 squares in it. What? So how many do we have? But isn't that I mean, do you need to calculate? You have so you have minus ones always on x, right? And then you have that times what? Minus 1, 1, 2, 3, 4. What? Ah, so different. Calculate the numbers different. Okay. Well, that's different. Okay. So number of different squares. How do we check? I guess we can just transform them into squares, right? No? Do we? No. Then just check. Bam, 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 no. I don't know. I don't know how to do it. How to check if they are. Yeah, I guess we can do. Yeah, we not transform into matrix themselves, but transform each possible um, each candidate into a string of some sort, right? Just to make it like a. Mm, yeah, that works. So we transform the matrix based on the items in it, whatever arbitrary order or whatever arbitrary UI, or sorry, ID generation based on this. Store those into a map, and then just if the ID is not present, add into the possible candidates, and if it is present, then just don't, right? That works, definitely works. Okay, let's do it. Let's just do it. Cool. Okay, just create a map to track IDs of the Tux2 matrix. And then iterate over matrix, generate ID of matrix, and increment if ID is not present, and then just return result, right? Bam, then result initial 0. Okay, now we also will create a map, which is string boolean would be fine. Then such map is fine. New hash map. That's doing. Okay, then iterate over the matrix int 0 0. Then yeah, matrix at length -1 because we are always going to take the one next to the current item. Do the same for the inner. Sorry, nope, this one. Y. Nope. Then this one, we will assume that the matrix has at least one. See the restrictions. Yeah, so at least it has one item and at least one length, right? So should be fine. Forget to update this one. This is also the same. All right, so we will what? Iterate over it. Okay, yep. Okay, now we will generate the ID. Then just the ID would be matrix on I, J. Then just this one, right? Matrix. That's just I on J plus 1. Right, and then just do the same for right this one. Right, so it should be I plus 1. Then it should be okay. So now we have the ID, and then just check, right? So let's just contains contains key ID, and then just result. If not, just map at put, right? Yep, ID and just put through. Or, oh yeah, is it get? Get. We can also use a set, right? I guess it's better to use a set. New, what's that? Hash set, and just set at ID, and then if it can, then just continue, right? So we don't need to. Let me just check. Yeah, this returns the boolean, right? So boolean, right? Okay. And if it can be added, then just return it. Huh? Right, works perfect, and almost in time. 10 minutes. Okay, let's run it. Nice, perfect. Good, we managed to solve 5 problems today. Let's just see what other people were doing. All right, pretty much something similar. In this case, the guy was just adding a tuple or 4, like, yeah, whatever the object, 4 items in it into the set. Yeah, same. The guy was creating, this person was creating the ID using the hash set. Yep, set size in. Okay. Oh, you don't need the thing. Same set. Yeah. Yeah, I guess makes sense. Instead of doing the result, just return the set size, right? Okay. Excellent. So it was fun to solve these problems today. I wish you to have an awesome or continue having an awesome weekend. See you guys later. Bye bye.